Assalamu alaikum. My name is Syed Mehdi Raza and I've been teaching O and A level students for more than 6 years for now. My topics are mainly physics, chemistry and biology, and apart from that I also teach business studies and Pakistan studies. So today we are going to be looking at the topics of O levels and A levels, which is the topic kinematics, and this is one of the beginners topics I would say in O levels physics, and it is one of the most interesting topics. So let's start. So what is distance? What is displacement? These two terminologies, distance and displacement, are the most I would say students get confused between the distance and displacement, but there's nothing to be confused about these two things, because distance is a scalar quantity and the displacement is a vector quantity. So what is the difference between a vector quantity and a scalar quantity? So scalar quantity has just a magnitude, while the displacement is a vector quantity, which means that it has a magnitude as well as it has a direction. Okay, so what is distance? Distance is the length between 2 points. Let's say we have a town here which is town A, and we have a town here which is town B, and we want to know what the distance is. Let's say there are swamps here and there are mountains and swamps. Let's say if somebody want to go from A to B, they will be bypassing the swamps and they'll be bypassing the mountains and they will be reaching B. So let's say length between A and B in this case is around 15 kilometers. So we'll say that this is our distance, okay, because it just has a quantity, it does not have any direction. But if we are talking about displacement between A and B, so displacement between A and B will be directly in a specific direction. Let's say if this is due north, so displacement will be A to B towards east. So we got to know that distance is a scalar quantity and it just has a magnitude. Let's say the distance in this case was 15 kilometers, while the displacement is just 7 kilometers. So when we come to the definitions of distance and displacement, we say that the distance is length between 2 points. This is for distance, and the SI unit for distance is meters. हम सिंपल कह देते हैं कि भाई जो डिस्टेंस बिटवीन लेंथ बिटवीन 2 पॉइंट्स, SI unit is meters. But for displacement, we say displacement the distance in a specific direction, or we can say linear direction. This is the key difference between displacement and distance. So displacement is the distance in a specific direction, or we can also say displacement is the shortest distance. This is another definition for displacement, which is the displacement is the shortest distance between 2 points. So now we know that this distance is a scalar quantity. Distance SI unit is meters, while displacement is a vector quantity. It has a direction, it has a magnitude, and displacement is the shortest distance between 2 points. In this case, A and B, the shortest distance was 7 kilometers, while the distance was actually 15 kilometers because there were hindrances such as swamps and the mountains. So whenever we are calculating the distance or we are dealing with displacements, we need to be very aware that whether we are talking about displacement or distance. So this is the key difference between distance and displacement, and the further quantities, which are the derived quantities such as speed, velocity and acceleration, will be depending upon the distance or either displacement. So for the first quantity which we will be discussing after distance and displacement. So what is speed? If we talk about speed, speed is the rate of change of distance. Or distance traveled per unit time. So speed is distance upon time, which is meters divided by seconds. ms minus 1 is the SI unit. Again, speed is a scalar quantity because it has distance which is scalar and it has time which is scalar quantity. So speed is a scalar quantity. Now moving on, we have another quantity which is known as the velocity. What is distance? What is the difference between speed and velocity? Is actually the numerator in case of velocity is actually displacement. So velocity is a vector quantity, and it is the rate of change of displacement. So again, its formula will be again velocity equals to distance displacement upon time, which is again ms minus 1. The basic difference between velocity and speed is that speed is a scalar quantity, velocity is a vector quantity. Velocity is speed in a linear direction or speed in a specific direction. Velocity keeps on changing and it also depends upon the direction. The best possible scenario to explain what velocity is like if you are moving around a roundabout. Let's say you are taking a U-turn with your car on a roundabout and your velocity is maintained at 5 meters per second. I would say that you are accelerating because your velocity is not 5 meters per second, it is changing because of the continuous change in directions. Because at every point your direction will be different and so your velocity will be different, and so in that case, although your magnitude is constant, which is 5 meters per second, but we will be saying that this object is accelerating. Same goes for the case of Earth revolving around the Sun, because the Earth is moving at a constant velocity. But again, since it's moving in a circular direction, circular motion, its direction is continuously changing, and we will be saying that it is changing direction, so the Earth is accelerating. So again, I have mentioned that accelerating, so next quantity will definitely be acceleration. And what is acceleration? Acceleration is the rate of change of velocity. Rate of change of velocity. So we will be saying that acceleration is v minus u upon time. So v is the final velocity, u is initial velocity. And t is time. So let's this time SI unit for acceleration is ms minus 2. And when we are discussing acceleration, let's do a short numerical and get a key explanation what acceleration actually is. So let's say we have a car which has started its motion, let's say from rest. A car started from rest and it achieved a velocity of, let's say it achieved a velocity of 15 meters per second in 5 seconds. So expression will be simply v minus u over time. In this case, final velocity is 15 meters per second. So we'll be writing 15. For u, since the car started from rest, so initial velocity will take initial velocity as 0. and we'll be dividing it by time, which is again 5 seconds. So 15 divided by 5, it will be 3 meters per second minus 2. So acceleration is 3 meters per second square in this case. So there is another term which is opposite that of acceleration, which is known as the deceleration. And what is deceleration actually? Let's say we have another term which is known as deceleration, or in some textbooks it is referred to as retardation. So what is deceleration or what is retardation? Let's put this into perspective. Like, say the car is applying brake. And the car was at, let's say, 25 meters per second minus 1, and it came to halt. In 5 seconds. Okay, so the car is applying brake at 25 meters per second, and it came to a halt in 5 seconds. Let's say the car started applying brakes and it came to a halt after 5 seconds, because that's the braking time. And now we'll have to find the acceleration. Acceleration is equals to v minus u over time. In this case, we don't have a final velocity, because the final velocity is the car is at halt, the car has stopped. So we'll take final velocity as 0 minus initial velocity was 25 divided by time was 5 seconds. So it is negative 5 meters per second square. So acceleration this time is negative, and negative acceleration is known as retardation, deceleration, and it comes into perspective when some body is decreasing its speed, or it is decreasing in velocity per unit time. So deceleration is opposite to that of acceleration, and it's usually applied to the cases in which the cars are applying brakes, or some body is slowing down from its original motion. So minus 5 meters per second square is the velocity in this case. So I hope your things are pretty easy at this level. We have discussed distance, we have discussed displacement, we have discussed speed, we have discussed velocity, and now we have discussed acceleration, and we have discussed deceleration, and we will be moving on towards the graphs, which are most important, and students fail to understand what graphs actually mean in this case. First of all, we'll be starting with the graphs of displacement time graph, and then we'll be doing the velocity time graph, and then we have just a small part in which we will be doing expression of free fall and terminal velocity. So let's just start with the velocity time displacement time graphs, and I'll be drawing some graphs and I'll be explaining them to you guys. So first of all, we will be doing the displacement time graphs. Okay, so we have different types of graphs. Let's say we will be taking displacement on y-axis and time on x-axis. Let's say we first have a graph of like this. We have this graph A. We have a graph which is again displacement on y, time on x-axis, and we have a graph like this. This is graph B. Then we also have a graph which is like this. Let's say displacement, time, another graph which is displacement, time, and another graph which I'll be drawing here as C and D, and this time it will be like this, again displacement and time. Okay, so moving on, in this case the graph is horizontal to and is parallel to x-axis, and let's say the object we are discussing here is a car. So no displacement is not changing, but time is moving on, so this means the car is at halt. Okay, So we'll be saying that car is at halt. In this case, distance and time are going at a constant rate. So for this, we'll say that the car is moving at a constant velocity. Let me tell you the displacement time graph gradient represents the velocity. So the gradient of the displacement time graph is velocity. Okay. So in this case, the car is at halt. The distance is not displacement is not changing. Time is moving on. The car is stopped. In this case, the velocity, constant. There is a constant velocity, displacement, and time are moving at constant. So this is a straight line graph. In this case, we have a slight curve, and it is increasing. So displacement is increasing much more faster as compared to time. So we'll say in this case the gradient is increasing, and since gradient is velocity, we'll say this is the graph of increasing velocity. We'll say velocity is increasing in this case, and for this case we will be saying that the velocity is decreasing because there is a decrease in gradient. You can see that the gradient is constantly decreasing. Displacement is increasing less as compared to time. Okay, so we'll say that this graph is of decreasing velocity. And for this case, this is again a straight line graph which was like this. In this case, again we'll say that velocity is constant, but since velocity is a vector quantity, it can be positive, it can be negative. In this case, we have a negative gradient, but the gradient is constant. So we'll say the velocity will be negative. Because the gradient is negative, the velocity will be negative. So we'll say the car is moving in an opposite direction with a constant velocity. The car is moving in opposite direction with a constant velocity. So we'll say velocity is constant, but the car is moving in opposite direction. So we need to understand that the gradient of the displacement time graph is velocity. So if we will be keeping that in mind, the graph will be pretty much simple, and we'll be just be focusing and looking at the gradient of the graph, and that will be giving us the velocity. Moving on, we have another graph which is known as the velocity time graphs, and these are the most important ones, and they do regularly comes in papers, and they do take a good amount of marks weightage in terms of marks as well. So first the graphs will be the same. I'll be just renaming that. In this case, we don't have y-axis as displacement. We'll be having velocity on y-axis and time on x-axis. Same goes for this one as well. So now, what does this graph represent? The velocity is the graph is parallel to x-axis. What can be inferred from this graph? It can be inferred that, let's say the velocity at this point is 50, and it's constantly 50 at this time. The time is moving on, the velocity is 50, the gradient is 0. So we know that there is no acceleration because the gradient is 0. There is no acceleration on this graph. The velocity is constant. So gradient, since this graph has no gradient, it is 0. So we'll say acceleration. We'll say no acceleration, constant velocity. That's pretty much simple. And we can also infer that the velocity time graph gradient indicates us with acceleration. So for the case of the displacement time graph, the gradient was velocity, and for the case of velocity time graph, the gradient is acceleration. And if we will keeping in mind the gradient, then we'll be easily able to interpret what graph is representing. For this case, it is a straight line graph, and it is a constant graph. So we'll say that the velocity is increasing with the same rate as time, and we'll be saying that in this case there is constant acceleration. In this case, again the velocity is increasing, and since the velocity is increasing and the time is not increasing and it's an increasing gradient, we'll say that since the gradient is increasing, we'll say that acceleration is also increasing. And this happens in most of the cases when you push the gas pedal of the car accelerates, and there is a increase in acceleration, and this graph can be easily plotted against it. For this case, the gradient is decreasing. Since the gradient of the velocity time graph is acceleration, we'll say that this is a decreasing acceleration graph. And for this case, we see that the gradient, again, this velocity is not constant. Velocity is decreasing constantly with respect to time, and we'll say that the gradient is negative. So we'll get negative acceleration, and we have already discussed that negative acceleration gives us deceleration. Okay, so this is the graph of deceleration, or we can say this is the graph of retardation. So now we have a holistic view of the velocity time graph. And one more thing to this graph is that the area under the curve, this area, the shaded area, and in this case this triangular area, in this case this area, in this case this area, and in this case this area, these all areas represent displacement. Okay, let's just do a simple case of a graph, and we'll be doing a numerical along with this, along with these graphs, and then we will be moving on towards expression of free fall and then terminal velocity. So let's say we have a graph, and this graph is like this. Now let's say we take time as 15 seconds, or let's just take it 10 seconds. 20 seconds, 30 seconds, and the velocity, we will be taking velocity as, let's say, 10. Okay, so for the first half from A to B, we see, and on y-axis we have velocity, on x-axis we have time, and from A to B we see that there is a constant gradient, and we say that from A to B the car is accelerating at a constant rate. Okay, from B to C we see that there is no gradient. We will be saying that the car is not accelerating but moving at a constant velocity of 10 meter per second. And from C to D we see that for the last 10 seconds the velocity is decreasing, and we will be saying that the car is decelerating. So there are three main components in which from A to B the car is accelerating. From B to C there is no acceleration, the car is moving at a constant velocity, and from C to D the car is decelerating, and we can easily find the total distance traveled. So total distance traveled will be the area under the curve. Area under the curve of AB, area under the curve of BC, and the area under the curve of CD. So we can the easy way is that, like, we can easily divide it as A area, B area, and C area. Let's say for the A area, it is a triangle, and the area of triangle is 1/2 into base into height. In this case, base is 10, height is 10, so it will be 1/2 into 10 multiplied by 10, 50 meters. For B to C, we see that it is a it's a square in this case. So for the square, the area formula is length into length, and it will be 10 multiplied by 10, which is 100 meters. And for the last 20 seconds, for the last 10 seconds, we have the base as 10 and the height again as 10, and this again a triangle, so it will be, for area C, we will be using the formula again of the triangle, 1/2 base into height, and 1/2 into 10 into 10, it is again 50. So total distance traveled by the car, let's say, for the first 30 seconds is 50 plus 100 plus 50, so the total distance is 200 meters. That's how you calculate area under the curve, and I could have easily taken this as a trapezium. That would have been more convenient for me, since we have two parallel sides and height. So let's say just do it with the formula of trapezium as well. 1 upon 2, formula of trapezium is 1 upon 2 into sum of parallel sides into height, and the parallel sides are 10 and 10 and the height is again 10, so it will be 1 upon 2 to sum of parallel side is, I guess, 30 plus 10 is 40 into height, and height is 10 again. So 40 into 10 divided by 2, so 400 divided by 2 will give us 200. So you can you can use both of the formula. You can use the formula of trapezium as well. It is more convenient. You can split the graph into the areas you desire. Let's say I had split the graph into A, B, and C. That was a long process, but you can do it either way. I have used the formula of trapezium as well. I have used the formula and I have divided the graph. So in both cases, area under the curve of the graph will give you displacement. In the case of velocity time graph, area under the curve or the graph is displacement. So total displacement in this case was 200 meters, and that's what the questions usually come in past papers, and we have done these questions. So you can go and do past papers on your own, and if you need any help you can just contact us for more details. Okay, now moving on towards the acceleration of free fall. So acceleration of free fall is basically anything falling under the gravity of Earth will fall at a constant acceleration of 10 meters per second. That not 10 meters per second exactly, it's 9.81 meters per second. But we usually estimate that in case of O levels, and we usually take it as 10 meters per second minus 2. So the acceleration of free fall states that anything, whether heavier, whether lighter, let's say in this case we are using a hammer and a feather, if they are both falling into the gravity of Earth, they will fall at the same rate and their velocity will increase at the same rate, which is 10 meters per second with the acceleration of 10 meters per second. For the first second, they will have velocity of 10 meters per second minus 1. For next 2 seconds, they will have a velocity of 20 meters per second minus 1, and so on. So their velocity will increase at a constant rate, which is 10 meters per second. So it doesn't matter if an object is heavier, it doesn't matter whether an object is lighter, anything falling into the gravity of Earth will fall with 9.81 meter per second acceleration. But that's not the case. In real world scenario, we have a lot of other factors influencing these things, and the most important factor is the air resistance. And this usually won't happen when you pick up a hammer and a duster. Let's say I have a duster here and I have a pen here, I am dropping them down, so definitely the duster will fall with a very slight rate as compared to the pointer, because the pointer is heavier and the duster is lighter, and there is slight more difference. The duster has a more surface area, so the air resistance is acting on the duster. That's why the duster have fallen with a very you can say with a very low rate as compared to that of the pointer. So so the most important factor which influences this free fall is the air resistance. Air resistance is always there. Air is all around us and it opposes the motion of the falling body in Earth's gravity. So we say that air resistance does not allow the object to accelerate at 10 meters per second. And if an object is falling from, let's say, and something is falling from a plane, and that object will definitely be falling at an acceleration of 10 meters per second or 9.81 meter per second, and the velocity of that object will be increasing. But when it will be falling into the atmosphere of Earth, when it will be falling in the gravity of Earth, there will be air resistance acting, on that object. For example, if this is an object, let's say it is a brick and it has a mass of, let's say, 10 newtons, and it is falling in the gravity of earth, there will be a resistance acting in the opposite direction on this brick, because according to the Newton third law, every action has an equal and opposite reaction. And since this brick is falling under the gravity of earth, the air molecules are pushing and applying the force against, which is opposite in direction and equal and opposite to the direction of the weight. So a point will reach where this reaction force, this opposite force, will be exactly 10 newtons. So now there is no net force, there is no resultant force acting on this brick. And since there is no resultant force acting on the brick, so we will be doing I will be involving Newton's second law, which is force equals to mass into acceleration. Since there is no resultant force, the acceleration will be 0. Since there is no resultant force, the acceleration will be 0 and there will be no more acceleration. An object will be falling with a constant velocity. And since object will be falling with a constant velocity, we say that that velocity is the terminal velocity. Okay, so terminal velocity is a velocity at which the weight of an object or the opposite force or the air resistance becomes equal to the weight of an object. So terminal velocity is a velocity at which air resistance on an object becomes equal to the weight of an object. For this case, if the brick was falling with 10 Newton per second, after some time of falling, the air resistance would become equal to 10 Newton per second, and these forces will be cancelling out each other. There will be no resultant force, so there will be no acceleration, and acceleration will become 0, and this brick will fall with a constant velocity. And that velocity will be known as the terminal velocity. So that's it for the topic of kinematics, and we will be covering more in the physics O-level physics series, and we'll be discussing forces. We will be doing all the topics and their past papers along with physics kinematics. So thank you all for watching this video. Do give a thumbs up to the video, do subscribe the video, and do share the video to your fellow mates so that they can get benefit in these crises of COVID times, because the centers are off. There is a process of social distancing, and do follow SOPs because the COVID is spreading at a very fast rate, and do take precautions. Take care of yourself and your family. Do give us subscription and do like the video. Thank you.